All right, everyone, here we go. As promised, here is my video for the last example problem on section 6.6, which is geometric sequences. So here's the problem that we're looking at. And the reason I wanted to do this as a video instead of in class is because it does require a little bit of graphing calculator work. So I do have Desmos up, so that if that is something that you guys want to use as well, probably not a terrible idea. So if you want to just take a second, pause the video, pull up Desmos so that you can do this either with me or, like on your own, whatever. But it's a good thing to be able to have the access to Desmos so that you can work on this problem and get this one done. Okay, so here is the problem that we're working on. It says clicking the zoom out button on a mapping website doubles the side length of a square map. After how many clicks on the zoom out button is the side length of the map? 640 miles. So today we kind of focused a little bit on those geometric sequences and figuring out what that common ratio was from term to term. So first thing I'm kind of looking at is, how am I getting from my first term to my second term, from my second term to my third term? And since these are geometric, we have to be multiplying each time. So to get from 5 to 10, I would have to multiply by 2. And then that pattern looks like it's going to continue 10 to 20. Again, you're multiplying by 2. So that common ratio that we talked about is going to be 2. Now, one of the last things that we talked about today was the idea of the formula for a geometric sequence. And that formula, if we just want to recall really quickly, sorry, I'm going to erase this so that I can write down our formula. Remember that our formula that we worked with was a sub n and then a sub 1 r raised to the n minus 1. So a sub 1 was our first term. And if I look at this example that we're given, our first term is 5. So we've got those couple of pieces that we need to help us come up with our equation. So our equation, just really quickly, a sub n equals, let's see, a sub 1 is 5. That common ratio is 2 raised to the n minus 1. Okay, now the only number we haven't dealt with on this is the 640 miles up here. Now that 640 miles is actually, like when I set up the equation, supposed to go over here to take place of this a sub n, because that's like the term that we're trying to get to. So I would set this up as 640 equals 5 times 2 raised to the n minus 1. Which, okay, that's all fine and dandy, but right now we don't have the skills to solve this. Those are skills that you're going to develop later in your mathematical careers. So right now, the one thing that we have learned how to do and the one thing that we know how to do is that we can take this equation and we can break it up into 2 pieces. So like this we can do as 1 and this we can do as 1. Sorry, I gotta get that 5 included in there. So we're gonna take and we're gonna separate these two into, sorry, let me just extend the page here really quick. There we go. We're gonna take each of those pieces and we're going to do 2 separate equations. So we are going to say that y equals 640, and that'll be y sub 1, and then y sub 2 is going to be 5 times 2 raised to the n minus 1. So now what we're going to do is we're going to go into Desmos, and we're just going to type those equations in. We're going to do y equals 640. So there's our first equation. So we're going to have to zoom out just a little bit so I can see that 640. Just a little further. Okay, so there's 640. And then for the next one, we are going to type in y equals 5 times 2. And then that's going to be raised to the n minus 1. Okay, so there's that other one. Now we talked about today how geometric sequences turn out to be exponentials, and right now it just looks like it's got a weird bend, but you have to remember that we are zoomed out so far that you can't see the gradual progression of it. You're just seeing a very, very intense shift of it. Okay, so now we're going to go where these two lines are intersecting. And let's see. So that point is at 8, 640. So what that means for us is that this point is these two lines are intersecting at 8, 640. What that means is that after 640 miles, that is going to be 8 clicks. So if I go back here, then I can go on to say, and I'm just going to type this out. So after 8 clicks, the length of the map will be 640 miles. All right, if you guys have any questions, just let me know. Otherwise, we'll talk about this a little bit more tomorrow, and then we'll see how the video side of things went, and hopefully we can kind of make some more decisions tomorrow. All right, have a great night, guys. We'll see you tomorrow.